Hello students, now we'll be solving memory-based question of GATE 2019. For more video solution on GATE 19, subscribe to our channel and don't forget to click bell icon for instant notifications.
Hello students, my name is Pranshu Mahajan, and in this video we are going to discuss a question from fluid mechanics, particularly belonging to chapter of basically fluid statics. And if you want to be brief, this question belongs to buoyancy. Okay, so let's have a look at the question first. So I think on your maybe left hand side you can see a cube of side 100 mm. So there is a cube, there is a solid cube. Its one side is 100 mm, and since it's a cube, so it will be 100 mm by 100 mm by 100 mm. A cube of side 100 mm is placed inside an empty container. So this is what the situation looks like. There is a container, and inside that empty container there is a cube. The density of the cube material is 800 kg per meter cube. Okay, up to what minimum height a liquid of density 1000 kg per meter cube should be poured in the container to just lift up the cube? Okay, now check. There is a container, there is a cube which has 800 kg per meter cube density. Inside the container there is a liquid also 1000 kg per meter cube density. The density of the body is less than the density of the liquid, so definitely the body is going to float in the liquid, right? So we are going to have a floating condition. But for the floating condition, what they are saying is that we need to just lift up the cube. Okay, what is the meaning of lifting up the cube? Now check. Now in this condition, when the cube is lying on the base of the container without any liquid, I think the weight of the cube will be balanced by the normal reaction from the base, right? Weight of the cube will be balanced by normal reaction of the base. Now you start pouring the liquid in the container. So what will happen? Because of the liquid, there will be some buoyant force also. So what you will do is, you will balance the weight of the body by the buoyant force and normal reaction. But when we are just lifting up the cube, this means the contact between the cube and the base will become zero. This means all the weight of the cube is balanced by buoyant force only. Okay, so what they are saying is that you have filled the liquid up to this much height, maybe up to this much height. Let us say this height is h, and because of this, the cube has just lifted up. So if you want to consider the normal reaction, that normal reaction will become zero. And for this equilibrium condition, what you will say is that the weight of the body is completely balanced by the buoyant force. Okay. Now check. How do you write down the weight of the body? I think that is written as density of body into volume of body into acceleration due to gravity. And how do you write down the buoyant force? It is equal to weight of displaced fluid. Okay, how much fluid is removed by the body? That is the displaced fluid. So if I consider the displaced fluid here, I think the portion of body inside the liquid, that is the displaced volume. So definitely this is the displaced volume, right? Right? So this is the displaced volume in the red. So what you will do is you will write down the buoyant force as density of liquid into volume of displaced liquid into acceleration due to gravity, where volume of displaced liquid is equal to the volume of body inside the liquid. Now if I consider the volume of body, I think I can write it as area of cross section of the body into total height of the body, and that total height of the body, that is like 100 mm. So you will have density of body into area of cross section of body into total height of body, which is 100 mm. Okay, and then there is a G also. And if you write down here density of liquid into area of cross section of the liquid, and I think this will be H, right? The volume of displaced liquid will be equal to this area of cross section, which is same as the area of the body only, into H. So here you will have rho L into A into H into G, right? Now check. I think A and A will cancel out. So this A and this A will cancel out. Similarly, your G and G will cancel out. So you are left with H is equal to rho B by rho L into 100 mm. I think they are asking us to find out H only, that is height of the water in the container. Now check, rho B is equal to 800 kg per meter cube. Rho L, density of liquid, is 1000 kg per meter cube. So 800 by 1000, that is 0.8. Now this is a ratio, so it is not going to have any units. So 0.8 into 100 mm, that is 80 mm. So your final answer is 80 mm. Right? So this is the correct answer. And I hope this rho B by rho L, in the classes we also say rho B by rho L is the fraction of a floating body inside the liquid. Rho B by rho L is the fraction of the body inside the liquid. So instead of doing all this analysis, we knew that the fraction of the body inside the liquid will be directly given as density of body by density of liquid. Now how do you write down fraction of body inside the liquid? So fraction of body means volume of body inside the liquid divided by total volume of body, and again that you will get as H by L. Okay, so anyway you can solve the question. Either you can use the statements directly or you can go by free body diagram as well. So I hope this video was useful for you guys. So it would be great if you can share the video with your friends also. This might help them out, and please like it and share the video. Thank you.